So today we are going to discuss the NOR gate. So NOR gate is a basic operation in Boolean algebra. So how do we achieve the NOR gate with transistor, which I have already explained in the earlier videos. Now we are going to achieve the NOR gate with IC. So there are already ICs available in markets, which has couple of NOR gates inside it. So I chose one of them. It is a IC of SN74HCT02N. So basically it is a 7402 IC. So it is a quad 2 input uh, IC. So it basically has four NOR gates, each one with two inputs. So the typical diagram is for this IC is this is the mark here. So from there we start counting the pin number 1 2 3 4 5 6 7. So it is basically a 14 pin IC. So uh, pin 14 and pin 7, these two pin are for the power, to powering the IC. So pin 14 is connected to plus 5 volt here, and pin 7 is connected to ground. So these are for to power the IC, and rest of the pins are for NOR gates. So it is like first NOR gate is like pin 1 is the output of first NOR gate, and 2 is the input for first NOR gate, and 3 is the another input for first NOR gate. And this goes on for other pins. So like the basic NOR gate operation is, as we know that there are two inputs A and B and one output. So whenever the both inputs are low, then NOR gate yields as a result 1. When one of the input are 1, then it uh, it, it outputs as a 0, and if both inputs are 1, then also it outputs as a 0. So this is a inverse of or operation basically. So when we talk about or operations, so we already know that for or operation, when one A and B or is operated with or operation, then it results in 0. So output of that 0 is 1. So basically it is a inverse of or operation. So now we are going to connect the IC. So I have already connected the pins, and the first three pin are for first NOR gates, first, second and third. So this is the output and two are inputs, and the fourth pin is the another output for second NOR gate, and these two are for input. And same goes for here. This is the output and this is the input, and this is the input for NOR gate. This is another NOR gate for this three pin. This is the output, and this one is the input, and this one is the another input. So let's connect the IC to the power. So this is a 5 volt power supply I have made with the typical phone charger. So let's connect. So as you can see, this one is for to show the or power in the IC, and all four gates are now 1 because we haven't applied any input on any gate. So this explains the first situations like 0 and 0, then all outputs are 1. So let's verify the first NOR gate. So these are two pins for, so I am going to connect this one here in the second pin, another I'm going to connect in the third pin. Okay, so if I power any of the input as 1, then output goes to 0. So this outer line is the positive line, and the inner line is the ground. So same for the other side. So if I power one input, then this goes 0. If I power another input as 1, then this goes 0. And if I provide both the input as 1, then also 0. So this explains the whole truth table here. So same we can do for other NOR gates. Like this IC has 4 NOR gates. So let me connect to the other NOR gate. So I have connected for this 4th NOR gate. So we remove the power out to show you. Like the pin 15th is the output, and 14 is the A input, and the 13 is the B input here. So this 4 input, and this is the output of the Y. So this explains here. So now I'm going to connect. Both inputs are 0. So now it is 1. So I'm going to connect either one of the input as 1, then the output will be 0. So this, the LED turns off. If I do it for other input, then also the LED turns off. If I do it for both the input, then it is also turns off. So this explains this truth table also. So this is complete NOR gate operations. We can do it with transistor also, so that I explained in another video.